Hi there! Today we're going to talk about permutation and combination. Our main objectives here is to define what permutation and combination are, illustrate the formulas for permutation and combination, define the meaning of factorial, show the difference between permutation and combination, and apply problem-solving skills regarding our topics for today. But first, let us focus on permutation. Permutation is a mathematical technique that determines the number of possible arrangements in a set when the order matters. We represent n as the number of elements in a set, and r as the number of selected elements arranged in a specific order. But then, how are we going to compute for that? Simple. We'll use the function factorial. Factorial is simply the product of all whole numbers from a given number down to 1. So if we are to find the value for 7 factorial, well, it is simply 7 times 6 times 5 times 4 times 3 times 2 times 1, which is 5040. Let's say there are 5 different persons A, B, C, D, and E. And then these persons are going to be seated on 5 different chairs. Determining how many possible arrangements could these persons be seated on 5 different chairs, we use the mathematical concept permutation. Here is the illustration for the problem. We can choose one of 5 persons to take their seat on the first chair, anyone from A to E. So let's put here 5. On the second chair, well, one of 5 is already seated on the first chair, so there are only 4 persons left for us to choose to have their seat on the second chair. And since there are 2 persons already who already took their seats on the first 2 chairs, we're left with 3 persons to choose from to take their seat on the third chair. Same idea goes with the fourth chair. 3 persons are already seated on the first 3 chairs, so we're left with 2 persons for the fourth chair, and only 1 person left for the fifth and last chair, since everyone but the last person are already seated. So, we apply multiplication for these numbers. That's 5 times 4 times 3 times 2 times 1, or simply 5 factorial. Calculating it, we'll have 120. So there are 120 ways we could arrange 5 persons on 5 different seats. But what if we are to arrange the same 5 persons we have last time, but then there are only just 3 chairs? Well, we'll do the same process again. We can choose one of 5 persons to take their seat on the first chair, anyone from A to E. So let's put here 5. On the second chair, well, one of 5 is already seated on the first chair, so there are only 4 persons left for us to choose to have their seat on the second chair. And since there are 2 persons already who already took their seats on the first 2 chairs, we are left with 3 persons to choose from to take their seat on the third chair. Regardless of the other 2 persons who won't have their seats, the numbers we'll get from calculating would be 5 times 4 times 3, which will give us 60. So, how does the formula for our permutation look like? Our n in both problems are the number of people to take their seats. That's from A to E, which is 5. Our r in the problem are the seats itself. On the first problem, we had 5 seats. On the second problem, we had 3. And so the formula for permutation is n factorial over the quantity n minus r factorial. On the first problem, we do substitution. 5 factorial over 5 minus 5 factorial. 5 factorial is simply 5 times 4 times 3 times 2 times 1, which is 120. 5 minus 5 is equal to 0. 0 factorial is equal to 1 by definition. So 120 divided by 1 is equal to 120. And so we have 120 number of arrangements for 5 people on 5 chairs. On the second problem, we do substitution as well. 5 factorial over 5 minus 3 factorial. 5 factorial is 120. 5 minus 3 is equal to 2. So that's 2 factorial, or simply 2 times 1, or 2. So we have 120 divided by 2, which is 60. And it is why we have 60 as an answer to the second problem. Try this activity. You ready? So here are the answers for our activity. A car race has 12 participants. How many different ways can first, second, and third occur? 1,320 ways. First, second, third, fourth, and fifth occur. 95,040 ways. Lastly, all 16 places occur. That's 479,001,600 ways.
Let us discuss about combination. What is combination? A combination is a mathematical technique that determines the number of possible arrangements in a collection of items where the order of the selection does not matter. In combinations, you can select the items in any order. Don't be confused about permutation and combination because unlike permutation, arrangement of items in combination doesn't matter. For example, you have A and B. In permutation, A and B can also be B and A, and that will be count as two arrangement. While for combination, A and B or B and only counted as one arrangement. Now that we know what is the combination, let's get its formula. The formula for combination is n factorial all over the product of r factorial and the factorial difference of n and r, wherein n is the number of choices and r is the number of item you will combine. So basically, when we are reading a combination, it is said to be as n choose r. Let's have a simple example about combination. Imagine you have candies and you want to give it to your 3 cousins, Alex, Bert, and Carl. Your number of choices is 3 since you have 3 cousins. If you only have 2 candies, then you will not be able to give a candy to one of you 3 cousins. So you can give only Alex and Bert, Alex and Carl, or Bert and Carl. That is only 3 combinations. If you want to use the formula for combination wherein your n is 3 and r is 2, then 3 factorial all over the product of 2 factorial and the factorial difference of 3 and 2. 3 factorial is 6. 2 factorial is 2. 3 minus 2 is 1. 1 factorial is 1. We have 6 all over 2 multiplied by 1, and that is equal to 3. Let's have another example. Imagine you are a coach of a basketball team. You have 12 players in your team and the only number of players allowed to play at a time is 5. So your number n, number of choices is 12, then your r, number of players to be picked is 5. So we have 12 choose 5. If insert it to the formula, then we will have 12 factorial all over the product of 5 factorial and the factorial difference of 12 and 5. 12 factorial is 479,001,600. 5 factorial is 120. 12 minus 5 is 7. 7 factorial is 5040. 120 times 5040 is equal to 604,800. 479,001,600 divided by 604,800 is 792. So you will have 792 number of combination. Have some examples regarding combination. Take note, after 5 seconds of flashing the problem, the answer will be revealed. It is suggested to pause the video while answering. 6 friends want to play enough games of chess to be sure everyone plays everyone else. How many games will they have to play? 5, 4, 3, 2, 1. There are 6, so the number of choices n is 6. To play chess, you only need 2, so your r is 2. 6 choose 2. 6 factorial all over the product of 2 factorial and the factorial difference of 6 and d2. 6 factorial is 720. 2 factorial is 2. 6 minus 2 is 4. 4 factorial is 24. 2 times 24 is 48. 720 divided by 48 is 15. There are 15 games or 15 combinations. Problem number 2. You are in a dessert shop. There are 7 different desserts. But you only want to eat 3 desserts. How many possible combinations you are going to pick? 5, 4, 3, 2, 1. There are 7 choices and you are to choose only 3. That will give us 7 choose 3. 7 factorial all over the product of 3 factorial and the factorial difference of 7 and 3. 7 factorial is 5040. 3 factorial is 6. 7 minus 3 is 4. 4 factorial is 24. 6 times 24 is 144. 5040 divided by 144 is 35. So there are 35 possible combinations. Problem number 3. There are 4 men and 5 women in a small office. The customer wants a site visit from a group of 2 men and 2 women. How many different groups can be formed from the office? 5, 4, 3, 2, 1. For men, you have 4 choose 2. For women, you have 5 choose 2. The final answer will come from the multiplying the answer of those 2. For men, 4 choose 2. 4 factorial all over the product of 2 factorial and the factorial difference of 4 and 2. 4 factorial is 24. 2 factorial is 2. 4 minus 2 is 2. 2 factorial is 2. 2 times 2 is 4. 24 divided by 4 is 6. For women, 5 choose 2. 5 factorial all over the product of 2 factorial and the factorial difference of 5 and 2. 5 factorial is 120. 2 factorial is 2. 5 minus 2 is 3. 3 factorial is 6. 2 times 6 is 12. 120 divided by 12 is 10. For the final answer, 6 times 10 is equal to 60. 60 possible combinations. And that's how combination works. Thanks for watching.